In this video, we will learn how to factor polynomials and find real zeros using the factor theorem. The factor theorem states that if a polynomial p of a equals 0, where a is a real number, then x minus a is a factor of the polynomial p of x. Conversely, if x minus a is a factor of the polynomial p of x, then p of a equals 0. If we are asked if x plus 3 is a factor of the polynomial function p of x equals x cubed plus 3x squared minus 4x minus 12, our x minus a is x minus negative 3. So we are going to determine if this polynomial function, when evaluated at negative 3, yields a value of 0. If it does, then x plus 3 is a factor of this polynomial function. Set up the synthetic division process as follows, with our a, in this case negative 3, outside the lines, and the coefficients of the polynomial in degree descending order, in this case 1, 3, negative 4, and negative 12, inside the lines. Start by dropping the leading coefficient of 1 below the remainder line, and multiply negative 3 times 1 to get negative 3. Place negative 3 below the next coefficient and add to get 0. Repeat this process of multiplication and addition until all coefficients are accounted for. Notice that our last instance of work gives us negative 12 plus 12, which equals 0. Since there are no more coefficients, and since 0 is the number we end with in our work, the remainder is 0. Thus, x plus 3 is a factor of this polynomial function. We can go further and factor this polynomial function now that we know at least one of its factors. This polynomial function factors completely to the quantity x plus 3 times the quantity x minus 2 times the quantity x plus 2. Let's look at another example. Is x minus 1 a factor of the polynomial function p of x equals x to the 4th power minus 6x cubed plus 29x minus 24? If so, factor completely. In this case, our a is 1, so let's use synthetic division again. Our a, which is 1, is outside the lines, and our coefficients, which are 1, negative 6, 0, 29, and negative 24, are in degree descending order inside the lines. Since there is no x squared term shown, it has a coefficient of 0. Again, we drop our leading term down and then multiply. 1 times 1 is 1, so we place 1 underneath negative 6 and add, getting negative 5. We repeat this addition and multiplication process until all coefficients are accounted for. At the end of the synthetic division, we get negative 24 plus 24, which equals 0. Therefore, there is no remainder in this division process, and x minus 1 is confirmed to be a factor of the polynomial function. Next, to factor the polynomial function completely, we can use our work from the synthetic division process to find the other factor to the original polynomial function. 1, negative 5, and 24 are the coefficients for the other factor of the original polynomial function, which are also in degree descending order, starting at a degree 1 less than the highest degree of the original polynomial function. Thus, x cubed minus 5x squared minus 5x plus 24 is a factor. You can try to factor x cubed minus 5x squared minus 5x plus 24 further, but it is prime and cannot be factored further. Therefore, our polynomial function in factored form is the quantity x minus 1 times the quantity x cubed minus 5x squared minus 5x plus 24.